In example 3, we need 3 definitions to go over, which is the analytical solution. For equation number 2, we have an integral of dp divided by p times 1 minus p over m is equal to the antiderivative of kt. And then we know that m minus p divided by p is equal to a e to negative kt. And then for in equation number 4, p of t is equal to m over 1 plus a e to negative kt, where a is going to equal m minus the initial value of p divided by the initial value of p. Now in example 3, an explicit solution of the logistic equation, we want to write the solution of the initial value problem from our previous example. And we want to use it to find the population sizes p of 40 and p of 80. And at what time does the population reach 900? So we're going to use equation 4. So the important information that we have is that k, the constant, is equal to 0.08. We know the carrying capacity m is 1,000 and the initial population is 100. So using this formula in equation number 4, p of t is going to equal 1,000 divided by 1 plus a e to the negative k, which is 0.08 t. And then we can also figure out what a represents by taking the carrying capacity, subtracting the initial population, and divide it by the initial population. So we have 1,000 minus 100, which is divided by 100, which is equal to 9. So in step 2, we can write p of t, which is equal to 1,000 divided by 1 plus 9 times e to negative 0.08 t. And now we can find in step 3 what is the population sizes when t is equal to 40 and when t is equal to 80. So plugging in t to be 40, plug it into our function, we get approximately 731.6. For when t is equal to 80, plug in 80 into our function for t, and we get approximately 985.3. And then step 4, which is the last part of the question, they're asking us if the population reaches 900 when p of t is equal to 900, which means we want to find out what is t, what is the time t. So we have our equation, which is 1,000 divided by 1 plus 9 e to the negative 0.08 t, and that's going to equal 900 because we want to know what is the time for when population reaches 900. So what we can do in order to solve, we can use some algebra. So we can take the reciprocal of both sides of the equation, because since we're going to be solving for t. And then we're going to multiply both sides by 1,000. And then if we reduce the fraction on the right-hand side, we get 10/9. And that's going to equal 1 plus 9e to negative 0.08 t. Then we're going to subtract 1 to both sides. So basically we're going to be subtracting 9 over 9 from 10 over 9, which becomes 1 over 9. And then divide by 9, which means this is going to be 1 over 9 times 9, which is 1 over 81. And then in order to solve for t, with the base of e, we're going to take the natural log of both sides. So we get the natural log of e to negative 0.08 t, which is equal to the natural log of 1 over 81. Over here, we know that we can get negative 0.08 t. Over here, with division, we can take natural log of 1 minus the natural log of 81. The natural log of 1 is 0. So we have negative natural log of 81 divided by negative 0.08, which gives us a positive. So t is going to equal the natural log of 81 divided by 0.08, which is approximately 54.9. So what it's saying here is that the population reaches 900 when t is approximately 55. And as a check on your work, we can graph the population curve in figure 4 to the right here and observe where it intersects the line p equals 900. So if you followed your cursor, it would indicate that at the value of t, which would be approximately 55.